Thank you all for having me. Thank you for having me. I'm really excited to present my capstone project and for the opportunity to relearn how to tie a tie after the pandemic. The title of my project is Embryorigami, the educational impact of 4D virtual folding embryo models on student learning and confidence. And that embryorigami specifically referring to the folding of the embryo during week 4 of development. If you have any questions, feel free to contact me. This is my email here, and it'll be located on the slides as we progress. First, some acknowledgements. My capstone committee, Dr. Lee, Dr. Salcedo, and Dr. Jennifer Stratford, as well as Jennifer Thurston as our program director, the MHA class of 2021, and the CU Anschutz MD class of 2024 for participating in my study. So for some background, embryology is a foundational subject in the study of adult anatomy, and it has implications for congenital conditions and anatomic variation. It's also very challenging for students because of the 4D changes that occurred rapidly in the embryo, and that 4D referring to the changes in space and time as the embryo develops. In anatomy as a whole, many effective teaching tools include detailed visual aids, and studies have shown that multimedia learning does enhance learning outcomes in anatomy education. There are images in embryology, but they're kind of limited to these two-dimensional textbook images that you can see here as kind of an artist display. That's located in the Embryology, or Langman's Embryology, the 13th edition. There are also few visual 4-dimensional educational resources that exist in embryology due to the fact that this is kind of a young science, meaning there are a lot of things being developed, but things have yet to be discovered and yet to be developed for educational purposes. And then additionally, development of the body cavity and how the embryo folds, which is shown in this image, is particularly challenging due to the speed of how quickly it changes, as well as the complexity of how it changes. And I thought this was particularly challenging when I took my embryology class, and that was echoed by a lot of my classmates. So I set out to develop a resource that shows this process in 4 dimensions. So to do that, I started in MATLAB, and I took serial histological sections taken from the National Museum of Health and Medicine, and I segmented them so these are all stacked up images, and I segmented them through the entire stack of images to create a model that looks sort of like this in MATLAB. I then exported that into Blender, where you can see this one looks a little bit more like Play-Doh, but it's quite jagged. So I smoothed that out in Blender and brought it into the gaming development software Unreal Engine 4, where I made it a little bit more biological looking, and understandable, and then did some user interface work to allow these students to interact with this resource. And I titled it the Virtual Folding Embryo, and I created 3 individual models, one at day 17 post-fertilization, one at day 19 post-fertilization, and one at day 28 post-fertilization. And what I like about this is these days correspond with what you saw in the previous image. So if I were to take a cross-section through any of these 3 images, these are the approximately what you would see. So describing that exact process in 3 dimensions. I have a short video here that shows the user interface of how the students would interact with this resource on a web browser format. So you can see you can rotate the models as well as show and hide the different structures. And then as you progress to the day 19 model, some things have developed, and I'll show you can kind of rotate and fly over and get different views of the model, and then you can bring up a short description from the buttons on the right, and those all are, each button corresponds with each of the different structures. The last model is showing that you can rotate all the way around and see the opposite side, as well as zoom in and see some of the underlying structures, and I'll show at the end. You can see the developing heart here at the end. So the aim of my study was to assess the educational impact of the virtual folding embryo, or VFE, and its impact on medical student learning, perception, and confidence. I hypothesized that the use of the VFE in an integrated embryology course would improve medical student learning regarding the body cavity formation and result in positive perception and confidence. So how did I do this? I recruited 155 first-year medical students who were enrolled in their gross anatomy component of their curriculum. And within that gross anatomy course was an integrated embryology component, which they were responsible for. The students watched a pre-lecture video from the year before and took a pre-quiz before coming to class. And then when they came to the active learning session, which was held on Zoom due to the COVID-19 pandemic, they were randomized into 2 groups. One group which would receive the VFE, and the other group would receive another control resource that was a 4-dimensional resource that did not have to do with the body cavity, specifically Marissa's resource. After 15 minutes, the students came back and individually took a post-quiz and survey, and that was during a synchronous virtual class component. So in each of their groups, they were given a study guide that was designed for about 15 minutes, and they walked through and then took a post-quiz afterwards. And those were analyzed on various different degrees using an ANOVA for the learning outcomes, a 1 to 5 scale for the survey responses, and a thematic analysis on the open-ended response questions. And so, how did the VFE impact learning outcomes? The answer is it didn't. Unfortunately, there were no differences from pre to post quiz as a result of the VFE and the control group, so no change from pre to post for either group, as well as no differences between the groups. So really, TLDR, no difference in any learning outcomes. But the student perception showed a little bit of a different story. In answering the question, the VFE was helpful for understanding embryonic folding. They rated this about a 4 out of 5, which is a generally agree that they thought the VFE was helpful. And then the VFE for understanding spatial and temporal changes, talking about that 4-dimensional change, rated about a 3.83 out of 5. So that's positive as well, generally agreeing. However, in their confidence in their own knowledge of embryonic folding, only a 2.18 out of 5. So generally disagreeing and not feeling very confident. And this was echoed in the student feedback from the thematic analysis. Some things emerged like the VFE was helpful for spatial relationships and visualizations of structures. So this specific student talking about the 3-dimensional aspects, visualizing the 3-dimensional aspects and tracking where different layers end up. So that was positive, as well as orientation better than the 2-dimensional images from the textbook. And that was positive as well. Some negative themes that emerged, slow interface response time, not enough time to use the resource. This student specifically kind of talking about those things. More time to digest the material, as 15 minutes is a short amount of time for this, how complex this material is. And then the afternoon after a test, not giving a lot of time to comb through the material. This was held the day after one of their unit exams. So it's understandable that they may have not felt as prepared as they needed to be able to progress through that 15-minute activity as efficiently as we expected. So some conclusions of the study: there were no significant outcomes between the control and experimental groups for the learning outcomes, as well as low reported student confidence. So unfortunately, the hypothesis was rejected for those 2 items. The students did report a high perception of the VFE, and that was positive, but it was definitely clear that the students would benefit from interacting with the VFE for longer. Limitations of the study: this was uncontrolled environment due to the COVID-19 pandemic, and that uncontrolled specifically referring to computer and connection issues. So the students were at home using their own software, their own connection. So if they had any trouble with opening the resource, it's understandable that that would eat into their time trying to resolve those issues, and that could lead to some frustration. Additionally, in the different groups, they were in groups about 4 to 5, and those group effects were not investigated. So in their individual VFE and control, they were in small breakout rooms, and how those interactions were not studied. The time limit, of course, 15 minutes being a short amount of time, being a challenge, as well as the level of preparedness because of that exam the day before. And lastly, some future directions of the study: controlling for those educational circumstances with computer hardware issues, connection issues would definitely be valuable for a repeated study. For the development of the interface, adding additional time points, more content, even an animation would be really great to see the effect of that. And then lastly, development of a mobile platform for further accessibility of the virtual folding embryo. But with that, are there any questions?
That was great, Andrew. Very impressive 4D models too.
Thank you.
Any questions?
Andrew, nice presentation.
Thank you.
Quick question: what 4D resource did you use for the control condition?
That was specifically Marissa's project that she just presented on. So the students in the control group were working on that embryonic virtual heart.
Thank you.
Mm-hmm.
Andrew, how would you build on this model going forward? What would you add to this model going forward?
So I would like an additional time point in between day 19 and day 28, as that's kind of a large jump and can be difficult for students doing that mental gymnastics. So I think an additional time point in there, as well as making an animation that transitions between the models for like future or further elaboration on how the actual change and how the different layers of the embryo evolve.
Andrew, I have a question as well.
Sure.
How is this packaged and distributed to students? You said that it relied on an internet connection for them. Was it not packaged in an app? Was it like a web browser based application?
Correct. So this was hosted on a web browser format. So you could just type in the URL, and then it would take you to this resource to interact just right on your web page.
Cool.
All right, thank you, Andrew.